Alrighty guys, I'm going to start doing average atomic mass problems with you. This one in particular is going to be number 10, and it's this guy on this sheet of paper right here. I know it's backwards for you right now, but you should be able and so comfortable with your review to know that what this page kind of looks like, and then that we're talking about number 10, okay? So the first thing that we're going to do is you're going to see that it says, okay, calculate the average atomic mass. That right there is your ding, ding, ding to just go ahead and start doing what we're doing, okay? So the first step in these types of problems is that you're going to take the percentages that you're given and you're going to yank them out and turn them into decimals, because the periodic table of elements doesn't have anything on it anywhere that's a percentage. So I'm going to pull out the percentages that are listed for us. The first percentage is 0.337. Okay? Our second percentage that we were given is 0.063%. And the last one we were given was 99.660%. The absolute first thing that I want to do with that problem is I want to change it from percents to decimals. As soon as I get my video to focus. There we go. Oops, sorry. All right, so we're back. Okay. Sorry about that, guys. So you're converting those percentages into decimals. The easiest way to do that is to take the decimal place and move it 2 places to the left. When you do that, you should have an empty loop. Just fill it up with a 0, because that's what you're supposed to do. So 0.337% really becomes 0.00337. Same thing with this one. 2 places, placeholder, it becomes 0.00063. And this guy right here, boom, boom, becomes 0.9960. Okay? That's the first step. Second step is you're going to box in the mass numbers that you need to multiply with. So when you're looking at these problems, always pick the mass number that has AMU after it. That makes it the most accurate reading, and that's going to make your answer be as closest to the one that's on the periodic table if it's not exactly the one that's on the periodic table. Okay? So you should be currently boxing in the numbers, and I'm just going to write them out to the side so that we can remember them. But you should be boxing in the number 35.97 AMU. You should be boxing in 37.96 AMU. And you should be boxing in the next one, which is 39.96 AMU. Okay? So these numbers in your paragraph should all have boxes around them. Okay? So what we're going to do now is we're going to take the box numbers. We're going to take the decimal numbers that we have figured out, like this one, and this one, and we're going to multiply them against each other. So here's our first box number. I'm going to write that in. 35.97 times 0.00337. We're going to add that, because there's multiple isotopes, we're going to add that to our next box number, which is 37.96. We're going to multiply it by 0.00063. And then our very last thing that we're going to do is we're going to multiply those same group of numbers after it. So what we're going to do, and I'm kind of scared that I'm going to run out of space, guys. So I'm just going to take this adding and I'm going to put it down here, okay? So we're going to add on our last two set of numbers multiplied against each other. So that's going to be the box number first, which is 39.96, and we're going to multiply it by that decimal number, so that's 0.9960. Okay? You're going to start punching in some stuff in your calculator. What I want is when you guys do these kind of problems, please don't do them all in one line, because you're going to end up missing a parentheses, and what it tends to happen is that kids get really caught up in that syntax error or really caught up in the math, and that they forget that you can just multiply them together and then add them all up at the end. So that's what I'm going to do. So I'm going to say equals. I'm going to multiply these two numbers together, and I'm only going to take the first 4 numbers after the decimal place. So you should be typing in 35.97 times 0.00337, and what you should get on your calculator is 0.1212. Okay? That group is done. Then we're going to do the addition sign, and then we've got to do this group. So you should be punching in your calculator 37.96, and you're going to multiply that by 0.00063. When you do that, you are going to get some numbers, and remember, I only want 4 of those numbers after the decimal place, so it will become 0.0239. Okay, now that group is done, so I'm going to put a little plus sign here, and I'm going to multiply these two numbers together. So right now, you should be punching in your calculator 39.96 times 0.9960. When you do that, you're going to end up with 39 point, and remember, 4 places after the decimal, so 800. Now check out our 4th spot. You're going to be finishing it out with 1 6 right here, but I told you I only wanted 4. So does this 1 stay a 1 or does it become a 2? If you don't know, well, here's how you figure it out. Look at the number that trails the last place that you need. This is our trailer number. It's a 6. If there's a number that's 5 or more as your trailing number, then the number that we need gets rounded up to the next number. So our 1 becomes a 2. Okay, now what you do is you do simply what it reads as. Type these numbers in and add them all together. When you do that in your calculator, it's going to pop up with the answer 39.9453. But if you go back to your problem, it says calculate the average atomic mass of argon to 2 decimal places. So we only need this decimal place and this decimal place. So what we're going to do is rewrite the answer. We need 39. We need the 90 part of it. Excuse me, the 9 part of it. But now we need to decide if this stays a 4 or if it goes to a 5. Looking at the trailer number, we see that it's 5 or more, so we see it's a 5. So this number does not stay as 4, it becomes a 5. So your new answer should be 39.95, and it has AMU as its unit. You box it in, and then you should be good to go.